Okay, thanks very much, Kate. Yes, well, first of all, I'd like to thank Shane because he's very conveniently proved that you do get space-time clustering. And really, the aim of this talk is to do a bit of kind of space-time visualization 101. So the idea is perhaps that rather than so much the modeling aspect this time, it's actually looking at data and seeing visual ways of identifying where there are clusters in space-time. And I think most people are used to looking at maps and seeing data on maps. But there's a third dimension in here, the dimension of time, and how we kind of make use of that. And so I want to kind of illustrate that idea and use one particular practical example to do that. The thing I'd like to talk about is something that I think quite often appears in the news these days, and that's the idea of disturbances and public order events. And in particular here, although I think I've said it's looking at space-time patterns in crime, in this case it's actually call-outs, so they aren't necessarily going to be crimes. These are incidents where the police may be called out, and hopefully if things are dealt with well, it won't actually end up in a crime. But what the police need to know maybe is when these things are likely to occur, and in particular at what time of day they might likely occur. And the point is, I mean, you can see lots of these photographs. They come in the papers and on the TV all the time. These sort of things of you know, kind of you know, drunken incidents on sort of weeknights, and particularly maybe Friday and Saturday night. And quite often, again, as it's shown there, this involves the police being called out to these places. And what we're looking at here is a data set that's actually quite old now. It's about 10 years old. I think it was 2001, so actually 11 years old. And this was based in Cardiff. And essentially what we had was the incident where something was reported and the time that it was reported. So these weren't actually the time that the police arrived, but it was the time that this got into the command and control centre. And I think we had something like, if I've got the number right, and I'm doing this from memory now, it was about 11,000 incidents over a 1-year period, and these were all in and around Cardiff. So that's the data set that I've been looking at here, although obviously you don't necessarily have to look just at that data set. And basically, the point is that, again, just to reinforce a bit of what Shane's been saying, that location and time are both important in this. The things that people do throughout the course of a day means they move around throughout the day, and at certain times incidents are more likely to occur. So for example, in this case, this is a couple of guys enjoying a bit of a sherry before dinner, and usually the circles I, well actually I was going to say the circles I move in, they usually have it just in glasses, but yeah, perhaps I'd better, yeah. But you know, the point is that at that point that's maybe something that's happening in the early evening, and maybe it means there's going to be, if there's going to be incidents coming from that, they'll happen perhaps in the early part of the evening. Later on, you get maybe certain kinds of incidents happening actually in and around bars and so forth. And one of the things that quite commonly happens, as far as I can see, and certainly chatting to people working in Cardiff, and I've also seen this in other places, a particularly bad spark point is taxi ranks at about 1:32 in the morning. Basically, centre of Newcastle is a great place to be in the nightclubs at 1 o'clock in the morning. Then the nightclub's shut, everyone wants to get home, it's raining, and they get fights, and they're in and around the taxi ranks. 2 hours before, they're not really worried about that. So the point is that depending on people's behaviour patterns and where they go throughout the day, there'll be different places where there are going to be incidents actually occurring. So location and time are both important. They're important for various different reasons, and certainly the kinds of crime that Shane was talking about, they'll have certain kinds of patterns, but they also will for this kind of incident as well. So very simply, I suppose what I want to talk about is the way that you can actually visualize these patterns. So we have this quite large database, and what we've done is, this was a database from the Command and Control Centre. We took out, selected out the public order incidents, and we have their location that was reported, and we also have the time of day that they were reported. So one of the first things we can do, and I think a lot of these visualizations don't actually have to be stunningly sophisticated. Sometimes it's the simple ones that are quite useful tools as well. And all we've done here is we're looking at data by time of day. So we're thinking of the data, if you like, as being cyclic data, in that you know, the time of day, it's something that starts at midnight, then runs through the day and returns back to midnight again. So what we've done here is we've taken out the information about what date these events occurred on, although we do have that. We just took the time of day into account. And then we plotted a graph like this. And essentially this circle, that top of there is midnight, that's midday, so it's like a 24-hour clock face. And then we just stack the points up. In fact, each of those doesn't represent one single crime. I think they represented 20. I can't remember the exact number. But the idea is you can use this just to see the times of the day that crimes most commonly occur. And you can see this kind of peak building up, bearing in mind this was before 24-hour opening, and a lot of places did have this tendency to shut at around 11. And there was a lot of incidents around 11 and 11:30. Then there was a bit of a lull, and then it seemed to go up again at about the time that the clubs were shutting down. I'm sorry, this is just Friday nights, not all nights, so we've particularly taken out Friday there. So possibly during the week you might get slightly different patterns because there wouldn't be so much use of the clubs. But you can see distinct patterns in there, and what's quite interesting, again, what possibly hadn't predicted, there seems to be another lull, and then it comes up again at about 3 or 4 in the morning, interesting. And then it more or less dies away and virtually nothing happens until, again, sort of early evening the next, on early evening on a Friday night. So basically, that's just a very simple graphic, but I think one of the things that's sometimes worth bearing in mind is that you see a lot of graphics and they're very visually stunning, but sometimes graphs shouldn't just have a wow factor, they should have an aha factor where you say, oh yes, I see what's going on here, and they're not always the same thing. And the thing you want to look for is when you see a graph with a wow factor, has it also got an aha factor? And if not, then maybe it looks nice, but you know, it doesn't necessarily mean it's going to be that useful. This is what happens when I split my data into the 7 days of the week. So again, sorry, the writing's a bit small there, but Saturday's that one there, then Friday, Thursday. So Thursday, Friday, Saturday are here, and these are Sunday to Wednesday. And you can see a number of features in those. Firstly, generally speaking, Friday and Saturday have slightly more points occurring on them than the other days of the week, which is perhaps not particularly surprising. You can also see 1 or 2 slightly different patterns. So that peak sort of after midnight is perhaps occurring less on the, certainly the Tuesday and Wednesday. Interestingly, on the Monday, it is occurring a bit. The only thing I can think of there, a lot of club student night Monday night, but might be wrong about that. But that's a sort of hypothesis you might be able to generate and see what's going on from there. This also illustrates a guy called Edward Tufte, who writes a lot about visualization. He talks about the idea of when you're trying to show patterns and compare things, in this case days of the week, the best way to do it is what he refers to as small multiples, i.e. don't try to represent everything on one graph. It's a better idea just to have a small number of separate graphs showing the same thing. It just tends to have more visual impact, and it's just quite a useful thing to remember sometimes. But that said, the other way I've looked at this sometimes is just to actually, instead of having a daily cycle, you could actually have a weekly cycle of this. And then what I've done here is now my circle runs the whole week round. So each of those segments is a single day. And so what I've done now is collapsed my times of day to basically run for an entire week. And again, this is over a 1-year period. And you can see there, again, that's the Saturday and Sunday peak. That's the Friday, Saturday, and so forth. And you can see there are distinct changes in the pattern as you go around the week. And as it's been pointed out, the other thing you could also usefully do is possibly put some kind of other information centrally in here. So if you wanted to show things like the times of opening and closing of pubs and things like that, and the different patterns perhaps in different days of the week, you could put that in there. That was actually less relevant at the time because basically, as I say, it was before the 24-hour opening, so there was less variety in that. But now that probably would be quite useful. And then finally, what I've also shown is how you can try to convert your just raw data that I was showing before into a kind of probability distribution. So this is more like a probability curve, more of a mathematical model where I've tried to obtain a level of risk, a more general thing, throughout the week. And that might be useful again in terms of simulations, things of that sort, because these actually translate directly into probabilities that I've obtained from those data. And I won't go into the maths of that, but effectively there are ways you can take that raw data and estimate the probability curve that that's coming from, and that's what one of these graphs do. Okay, so I've talked a bit about how you can deal with things just in terms of time, But the point is these data also did come in time and in space. So the way you can think of that is a kind of space-time cube. You've got the usual x and y dimensions of space, and again, in terms of visualizing crime in space, I guess I need to say less about that. It's quite usual for people just to plot points of crime on a map. And if you've looked at the Police UK website, although there's some complications about representing it exactly that way, you get the general idea of how you might represent crimes in space. But what I'm doing here is I'm doing them in time and in space. So if you like, the x and the y here, the base of this cube, are just the location throughout Cardiff, and the time factor is then this z direction, the kind of up and down direction, and each point here now represents the location in space where a crime occurred and the time of day it occurred. So you can see that, for example, in certain areas here, there's just a general gap, which means this is an area of space where there's very, very few crimes at any time of day. There are other places where there's much more density in terms of the crime at certain times of day than others, but some places where it's about the same throughout the day, and others like here where it gets busy, then dies down and then comes up again. So there are differences in the daytime characteristic. And again, I should point out that this is overlaying all of the days in my study into the one 24-hour period. Otherwise, that would be one hell of a day in Cardiff. But basically, that would be your sort of public order incidents in that day. But that's a fairly straightforward way to visualize points in space and time, literally just to plot them in 3D. The software I use to do this is a thing called OpenDX. I don't actually do it that way now. I use R. There are actually functions in the package R for anyone who wanted to do that in practice. One very important thing there is it's important to be able to interactively rotate that, because looking at it one fixed angle, you can't see all of the patterns. And really, 3D stuff only ever works when it's interactive. What we could do then is go on to this probability distribution idea, like I did with the space-time stuff for the day. But the problem with doing that in 3D becomes evident when you look at this diagram. Again, the idea now is to get something that's kind of smoothly varying throughout this cube. And whereas before it was just smoothly varying something onto a curve on the surface of a circle, because this circular cyclic nature of time of day, now I've got these sort of three dimensions to do things in. And one way you could do it is to imagine this cube kind of being filled with gas, and the colour of the gas sort of changing colour according to the intensity. And you can sort of see when you do that what's happening there. These are the areas of the higher intensity, but it doesn't work brilliantly, so we've had to try an alternative approach. One way to think of the alternative approach is to say, again, we do these smooth curves, but we split our time of day into lots of different layers. So for each of these layers, I've worked out the relative intensity, and I've drawn some contours on here. And the idea of the contours here is they're meant to contain 50% of the recorded incidents. So I've got these four layers. If you have those maps, it makes it difficult to see, so let's take them out and just put the contours in. And then that's sort of like lots of 2D structures, so let's join them together to make a 3D structure. And you'll notice here I've also not just done about 4 of them, you do a lot more than that. You do maybe one every half hour. And you can kind of join those structures together. And finally, using the visualization stuff, the package, you can kind of stretch a kind of skin over them to see this object like this. Now, this is still a bit abstract. If you're trying to show someone who's interested in managing crime one of those things, they'll wonder what on earth you're talking about. And I'm quite aware of that. It is important to do something realistic. So we have to go one step beyond that. And first of all, you can do things like zoom in on different features here. But the trouble is you can see the features, you don't really know what they mean. So what we have to then do is actually move on to some kind of visualization software like this. And what this does is, in fact, as I say, each of the points on that surface correspond to contours on an individual map. Now, although you don't necessarily understand what that feature is actually showing you directly, what you can do is you can see where there are interesting features. You can notice, whatever it might mean, that there's a gap there, or there's a new part sort of forming at some point here, things of that sort. So the idea with the interactive layout, and this is something maybe that a crime pattern analyst would have to do, is to move this this kind of plane backwards and forwards along in there, and that cross-section corresponds to an individual map. And then in a linked window, although this doesn't come out particularly well, you show a typical sort of map risk window, and that can go back to showing things on a real-world map and showing you where that means that the crime is at higher risk. And obviously, maybe this is something that a sort of intermediate person who's got to kind of translate these patterns into something that can be more directly communicated to people responsible for dealing with these crimes can deal with. But the idea is by producing something like this and linking these things up, you can get a kind of visualization tool that might work. And as I say, we're not actually looking at doing it this way for the time being. It's something we might want to do in the future, probably using R, or possibly just through a website or something like that, but having a sort of easier to use interface. But it's also the sort of thing that you can link, although I've not shown it here, all kinds of other information to that and try to come up with explanations as to why you're seeing the patterns. And the other thing that might be of interest is, again, the point that Shane made about sudden changes in the risk. At the moment, the model we use works with very smooth changes, but I've actually written a paper not to do with crime pattern analysis, but about how to fit surfaces where there are discontinuities, but not just ones like roads where you know where they might be, but how to try to detect those in the data. And we're thinking about trying to use maybe something like this in here to see what sort of things you might be able to do. But generally, that might be another sort of tool that might be helpful there. So, yep, really that's about it. And so, yeah, happy to answer any questions if there's any time. Thanks very much.